Okay, hopefully you completed the warm-up and you're just kind of checking over your work and answers. Today we're going to be looking at solving some equations using logs. Yesterday we were solving these exponential equations trying to get the bases to match so that we could set the exponents equal to each other. In this case, there's no way that we can make that happen. So what we need to do is we need to look at which term has the exponent that we're solving for. And it would be this term, the 10 to the x minus 1. And so what we're going to do is we're going to use a common log, a log base 10, so that we can get that variable out of the exponent, because we know the value of this is just 1. And then I will have, or is just, excuse me, the exponent, because the bases are the same. So then I will just have my exponent equal to the common log of 25. And now it's just like any other equation that we would solve. We're going to get the x by itself. And I have common log 25 plus 1. Or it might be better to write it as 1 plus the common log of 25, because then we're going to go to our calculator and we're going to put this expression in and get a decimal approximation. So 1 plus, we're getting our common log of 25. And we hit enter. And we get, let's go out to the hundredths place. So 10, let's go thousands, tenths, 100,000. So this would be 2.398. Okay. Go to the next one here. I am noticing that the variable is not in the exponent this time. It's as part of the argument of the natural log function. So now my strategy, this strategy where we had it in the exponent, we used the log. Here we're going to use the strategy of rewriting this in exponential form. So we start down at the base, and we say e to the fourth is equal to 2x plus 3. And then again, this is just like a good old-fashioned equation. And I have 2x's are equal to e to the fourth minus 3. I would divide both sides by 2 to get 1x is equal to e to the fourth minus 3 over 2. And again, we're going to get the calculator and get a decimal approximation for this answer. So we'll set up our fraction, numerator, denominator, and we want to put in e to the fourth minus 3, second, natural log, e to the fourth, make sure you get out of the exponent, and then we divide all of that by 2. And we put 25.799. All right, I'd ask that you kind of stop the video and try these two on your own, and then check back after you've tried to do the two on your own. All right. One more problem we want to look at today is just using logs and exponents and trying to solve equations that model real-world situations. So we're back to that magnitude problem that we had the other day with Taylor and Chen. And we've got our seismic energy X measured in joules can be estimated based on a magnitude of M. And we've got the relationship between these two quantities is X. Seismic energy can be calculated by taking 10 and raising it to the 1.5 times the magnitude plus 12. And then they ask us, what is the magnitude of an earthquake with seismic energy of 4.2 times 10 to the 20 joules? So this is our X. 4.2 times 10 to the 20 joules. And that's equivalent to 10 to the 1.5 M plus 12. And what we want to do is solve for M, the magnitude. And we notice that it's in an exponent, and the base on the exponent is 10. So this is where we're going to use our common log. We know that when the bases match, we're just going to write down our exponent. And then we're going to solve for M. So we would subtract 12 from both sides. And then ultimately, we're going to have to divide both sides by 1.5. And then now at this point, this is when I get the calculator, not a minute before then. And so we get our calculator, and we're going to type into our calculator that entire expression. Oops. Let's see if I can do that again. Should I move this over? No, it's not going to let me do it. All right, so I'll just have to remember the expression. The expression is, let's get our numerator, denominator. Try it one more time. Nope. Oops. Crud.